There are many other types of discrete probability distributions. The geometric distribution is another such distribution. Before we talk about the geometric distribution, let's first review the binomial distribution because they're both somewhat related. The binomial distribution of a random variable x, which represents the number of successes in a Bernoulli trial, is given by this formula. The important thing here is that n is the number of trials, and that's fixed. So that's a fixed number, like 10 trials, 20 trials, 100 trials. X here is the independent variable, and that's the number of successes. So x is what goes into the binomial distribution function, and you can calculate the probability of exactly x successes in n trials. And this n with an x in parentheses, again, that's the same thing as n choose x. So it's the combinatorial. You can also use the combin function in Excel. And p is the probability of success of each independent trial. An example of binomial distribution problem would be you are selling Girl Scout cookies door to door. The probability that any single house will purchase a box of cookies is 20%, so that means our probability of success is 0.2. What is the probability that you will sell 4 boxes of cookies in 10 houses? So the number of trials here would be 10. The number of successes would be x equals 4. So we could write it like this, f of 4 successes, exactly 4 successes. We can write it as such, and when you plug this into your calculator, you get about an 8.8% chance. About a 9% chance that you're going to sell 4 boxes of cookies in 10 houses, and that's exactly 4 boxes. Now what if we had asked at least 4 boxes? Well, that would be f of 4 plus f of 5 plus ... all the way up to f of 10 at least. This is also 1 minus the cumulative binomial function up to and including 3. So that's how you can calculate things like at most and at least. Now let's take a look at the geometric distribution. To introduce this, I've got a similar example. You're selling Girl Scout cookies. The probability that any single house will purchase a box of cookies is 0.2, so same as the previous example. So in a geometric distribution problem, we might ask, what is the probability that your first cookie sale, and that's important, it's always the first success in the geometric distribution, will occur on the third house, the fourth house, the first house, the second house, the nth house in general, or the xth house is how we use it in the formula. So the geometric distribution answers the question, what is the probability that the first success comes on trial x? Let's derive this real quick. Let's just say we had a probability of success that's p, and we have one trial and we get a success. The probability of that occurring is just p, right? If we have one trial, we get a success. That's the probability of success, p. If we have 2 trials in order to get our first success, that means we have a failure and a success. And in that case, the probability of a failure is 1 minus p, and the probability of a success is p. We could have 2 failures, then a success. And in that case, we would get the following. That would be the probability that the first success comes on the third trial. And in general, if we have X number of trials required to get that first success, then that means we have X minus 1 failures. And the probability of that occurring is 1 minus P to the X minus 1 times a probability of success, which is P. And that's exactly what the geometric distribution says. So the probability of this occurring, the first success occurring on the xth trial, is given by this formula. Just to kind of sum this up, the geometric distribution, it also depends upon a Bernoulli trial, independent trials with probability of success P, and we either have a pass or a fail. So the geometric distribution gives you the probability that you need X number of trials to get the first success. And this, again, is the geometric random variable X, and the probability function is given as follows. So it tells you the probability that the first success comes on exactly the Xth trial. Let's go back to this example here. Let's calculate the probability that the first cookie sale will occur on the third house. That means x equals 3, and we can plug that into the geometric distribution function. F of 3 equals 1 minus p raised to the x minus 1 times p, and when we plug that into our calculator, we get 0.128. that would tell us that we have a 12.8% chance that our first cookie sale will occur on the third house. So it's just telling us the first success. What about something like, what is the probability that your first cookie sale will occur before the third house? Well, before the third house, we could sum when x equals 1. We can't use x equals 0 like we can in the binomial distribution, but we can use f equals 1, f equals 2, plus f equals 3. And that's also equal to the cumulative geometric distribution function, capital F of 3. And so you could plug f of x equals 1, x equals 2, x equals 3 into the geometric distribution formula. So in summary, for the binomial distribution, we have a fixed number of trials, n, and the independent variable is the number of successes, x. The output of the binomial distribution is the probability that we will get exactly x successes in n trials. For the geometric distribution, we have a fixed number of successes, not trials, which in this case is exactly 1. You'll see in the next screencast on the negative binomial distribution, we have a fixed number of successes, but it can be greater than 1. So it turns out the geometric distribution is a special case of the negative binomial, which you'll learn next. We are interested in only the first success only with the geometric distribution. The number of trials, x, is the independent variable, and that's the number of trials required to get the first success. The output of the geometric distribution is the probability that we will get our first success in x trials.